In this video we have polynomials of degree 3, polynomial equations of degree 3, and what we are going to do is to solve these polynomial equations of degree 3 using a Horner scheme. I will go through details for the first one and then I will do rapidly the other questions. You have this polynomial of degree 3. What is a polynomial? A polynomial is a function where it has terms of x, x to some powers involved together. You have x to some power plus x to another power, and here also you have some coefficients in front of the x to the power of 3, and here x to the power of 2, x and constant term. You have combination of coefficients and monomials of x, powers of x, combined together. What we are going to do here is Horner scheme, and what we are going to do is to take the coefficients of this polynomial. In order to use the Horner scheme, we need to write the polynomial in descending powers. So we start with the biggest power is x to the power of 3, and then x to the power of 2, and then x to the power of 1, and x to the power of 0, which is the constant term, etc. And we use an initial guess here. In all of the examples, the initial guess is 1. If you put x equal to 1 here, you get 1 minus 6 plus 11 minus 6, which will lead you to 0. So I need the coefficients of the polynomial of x cubed is 1. The coefficient of x squared is minus 6. The coefficient of x is 11, and the constant term is minus 6. My initial guess is 1. I use the elevation here. I elevate the elevator for 1. I put 1 here. Then I take 1 times 1 gives me 1. Minus 6 add 1 is minus 5. Minus 5 times 1 is minus 5. 11 plus minus 5 is 6. 6 times 1 is 6. And here I get 0. So my polynomial px can be written as x minus the initial guess, which is 1, times the coefficient. Now the polynomial that I have in this bracket is 1 degree less than my initial polynomial, so it should be polynomial of degree 2. The coefficient of x squared is 1, so it's 1 times x squared. Minus 5 is the coefficient of x, plus the constant term, which is 6. See, now I have split this polynomial into a product of polynomial of degree 1. This here is polynomial of degree 1. And this is a polynomial of degree 2. I can factorize the polynomial of degree 2 is a quadratic equation by finding the roots. So I can factorize this. X squared minus 5x plus 6 can be written as x minus 3 times x minus 2. So my p of x equals x minus 1 times x minus 2 times x minus 3. So I have broken the polynomial of degree 3. I have broken it to a product of 3 polynomials of degree 1. I will do the same process for the rest of the rest ones. I take the coefficients. I take initial guess 1. P of x equals x minus 1 times x squared minus 13x plus 42. So this polynomial can be written as x minus 1 times x minus 7, x minus 6. So here I have my factorization. Let's go to question 3. I find the coefficients of the polynomial. I kickstart Horner scheme with initial guess 1. I factorize this quadratic polynomial. And the roots, the solutions of this polynomial are 2 real solutions. What is the square root of 9 is 3. So I go back here and I have x minus 1 times x minus 5 times x minus 2. Here is my polynomial of degree 3 factorized. I use the same initial guess. What are the roots of this polynomial? x1, x2. The square root of 1 is 1. The first root is 4. And the second root is 3. So it's x minus 1 times x minus 4 times x minus 3. Question number 5. I take the coefficients of the polynomial. I kickstart by initial guess 1. P of x equals x minus 1 times x squared plus 3x plus 2. So I go back to my p of x is x minus 1 times the coefficient of x squared is 1, x plus 1, x plus 2. P of x equals x minus 1 times x plus 1 times x plus 2. P of x equals x minus 1 times x squared plus 7x plus 12. We need to factorize the polynomial of degree 2 by finding the corresponding roots. The x1 is minus 7 plus 1 over 2. That's a minus 3. x2 minus 7 minus 1 divided by 2 minus 8 over 2 minus 4. Okay, so p of x is x minus 1 times x plus 3 times x plus 4. Here the polynomial is a polynomial of degree 2x squared plus 0x minus 4. Here I can use the following identity: x minus 1 times x minus 2 times x plus 2, because x squared minus 2 squared equals x minus 2 times x plus 2. So my p of x equals x minus 1 times x minus 2 times x plus 2. Question number 8. I used initial guess 1 because if you substitute here 1 minus 1 is 0, and here minus 9 times 1 is minus 9 plus 9 is equal to 0. I elevate 1 here, minus 1 plus 1 is 0, 0 times 1 is 0, minus 9 plus 0 is minus 9, minus 9 times is, what is wrong here? Yeah, it's 0. Here is a plus, sorry. So it's p of x equals x minus 1 times x squared minus 9. 9 is a square number, so I can write x squared minus 3 squared. X minus 1 times x plus 3, x minus 3. Consequently, p of x, I have a polynomial of degree 3 broken up into 3 brackets of polynomials of degree 1, x minus 1, x plus 3, x minus 3. Question number 9. The coefficient of x cubed is 1, the coefficient of x squared is minus 1, the coefficient of x is minus 25, the constant term is 25. The initial guess, my root is 1. So the p of x equals x minus 1 times x minus 5 times x plus 5. Let's go to the last example. The initial guess is 1. 1 goes down, multiplies my root 1. Minus 1 plus 1 is 0. 0 times 1 is 0. Minus 30 plus 0 is minus 30. Minus 30 times 1 is minus 30. 36 here, sorry. 36. So my p of x equals x minus 1 times x squared minus 36. 36 is a square number. This is 6 squared. I have x minus 1 times x minus 6 times x plus 6.